Here we want to find the maximum and minimum values of a function f of x and y equals 81x squared plus y squared, subject to the constraint 4x squared plus y squared equals 9. Okay, so here we know that we need to satisfy, obviously, this 4x squared plus y squared equals 9. And because these are both positive terms, we know that the smallest possible thing that y squared could be is 0, which means that 4x squared has to be less or equal to 9, or x squared has to be less or equal to 9 over 4, or that negative 3 halves is less or equal to x is less or equal to 3 halves. Now, we don't know whether x will be at one of those extreme values, but we do know that x can't go beyond those two extreme boundary values. Similarly for y has to be between negative 3 and 3. For the same reasons, if x is 0, then y squared is equal to 9, so that if all of the weight comes from y squared, y can be no larger than 3 and no smaller than negative 3. Okay, so it's important to keep these two conditions in mind. We don't want to find an optimal solution that doesn't satisfy that first equation. Now, we also need to look at the gradient of f equals lambda times the gradient of g. Okay, so in this case, the gradient of f is going to be, if we look at this with respect to x, 162x is equal to lambda times gradient of this guy is 8x. And with respect to y, we've got 2y equals lambda times 2y. And we also have to satisfy 4x squared plus y squared equals 9. So these are the three conditions that have to be satisfied for every solution. Now, for simplicity, let's start with the middle equation. If we know that 2y is equal to lambda times 2y, then we can move this over and get lambda 2 times 2y, we can get lambda times 2y minus 2y equals 0, or 2y lambda minus 1 equals 0. All right, so to satisfy constraint number 2, then y has to equal 0, or lambda has to equal 1, or perhaps both. Now, just looking at these sort of individually, let's look at the y equals 0 case. If y is equal to 0, then in order to satisfy this guy, this tells us that x, 4x squared, has to equal 9, or x is equal to plus or minus 3 halves, right? It's our extreme case here. So we've got possible answers at 3 halves, comma 0, and negative 3 halves, comma 0. If we look at the lambda equals 1 case, well, that satisfies the second equation, surely. For the first one, that would force x to equal 0. So that would mean 162x is equal to 8x. So x would equal 0. And if x is equal to 0, in order to satisfy the last equation, y squared has to equal 9, which means y is plus or minus 3. So the possible solutions we get here are 0, 3, and 0, negative 3. So there are only 4 possibilities. 1, 2, 3, 4. I didn't do a good job of putting them in any sort of order here, but f of 3/2 comma 0, if we plug that in to our original function, we get 729 over 4. And because it's symmetric, that's the same thing that we get for f of negative 3/2 and 0. Now, if we plug in 0 and 3, then we get f of 0 and 3 equals 9, which is the same thing as f of 0 and negative 3. Again, there's a lot of symmetry here. So that makes this the maximum value, and this the minimum value. So the minimum value occurs at 0, 3 and 0, negative 3. The maximum value occurs at 3/2 and 0 and negative 3/2, 0. So 2 max values, 2 min values on these possible intervals.